This question is from GATE 2014 Mechanical Engineering Paper Set 2, question number 34. What is the natural frequency of the spring mass system shown below? The contact between the block and the inclined plane is frictionless. The mass of the block is denoted by small m and spring constants are denoted by K1 and K2 as shown below. So let's find out the natural frequency of this spring mass system. Now we can see that when the mass moves downwards, let's assume the mass is moving downwards due to its own weight, K2 will be compressed and K1 will be expanded. And both will have the equal deflection. The amount by which K2 compresses will be the amount by which K1 will be extended. Therefore, we can say that springs that have the spring constant K1 and K2 are in parallel combination. And we know that for parallel combination, we can calculate the equivalent stiffness of this system as addition of stiffness of both the springs. So we have it as K1 plus K2. Now this is so because we can equate the force taken by each of the spring. So if we have F is equal to F1 plus F2, F1 is force taken by this spring having spring constant K1 and F2 is the force taken by this spring having spring constant K2. So F we can write as stiffness into the deflection delta, and this stiffness is the equivalent stiffness of the system because this is the force taken by the system. This will be equal to F1 will be K1 delta 1 and F2 will be K2 delta 2. Now as the deflection is same for both the cases, we can take it common and it will be equal to delta. So it is delta into K1 plus K2 is equal to K equivalent into delta. So delta on both sides can be divided and give us 1. We have K equivalent is equal to K1 plus K2. And that's how we have the equivalent stiffness of a system in which springs are in parallel and there are two springs. We just wrote it as addition of the stiffness of the two springs. Let's now find out the frequency. Natural frequency omega n is nothing but root over equivalent stiffness of the system upon the equivalent mass. But here there is a single mass. This is a single degree of freedom system. So its mass is small m. We can directly substitute it as small m. So we have omega n equal to under root K1 plus K2 by m. This is simply the natural frequency of the system. If this formula is not known to you, the standard formula, you can use Newton's second law of motion. So by Newton's second law, we can write m delta double dot, delta is the response, m delta double dot plus K1 plus K2 equivalent stiffness of the system into delta. So this is the inertia force and this is the stiffness force of the system. This will be equal to 0. There is no external force here. This will be equal to 0. Now we can divide the complete equation by m. So we have delta double dot plus K1 plus K2 by m into delta equal to 0. You can compare this equation to delta double dot plus omega n square delta equal to 0. And when we compare these two, we have omega n as under root K1 plus K2 by m. This same answer. Let's go back and mark the correct option. Answer is given in option D. Under root K1 plus K2 by m is the natural frequency of this spring mass system. This is from the topic vibration analysis. So you can refer to the NPTEL video module 2 lecture 1 vibration model for further details on this. This video is from the course lecture series on mechanical vibrations by Professor Rajiv Tiwari. He is from Department of Mechanical Engineering, IIT Guwahati. I hope this solution will help you clear your doubt. Thank you.